Hey guys, I got my Red Bull, I got my water, and I think we're good. I think we can create this video. All right, this video is sponsored by, no, I'm kidding, it's not sponsored by anyone. All right, let's just get right to it. Well, I guess I sponsor it because, I root for it. All right, here we go, guys. UH test 2. This is some random one. 44, not bad for a first attempt. And let's get this going. So this dude right here just means area. So I'm going to calculate this area here in red. I'm going to calculate this area here in blue. And I'm going to add those two suckers up. So it looks like just trapezoids, guys. So trapezoid. So area of a trapezoid, base 1 plus base 2 times height divided by 2. So let's see. Base 1, let's call that 2. And then base 2, let's call that 4. Times height. My height is 2 divided by 2. And then plus, and then I'm in blue here, or actually it's a minus. So minus, I'm going to subtract the area in blue. So that is, let's see, 1, 2, 3, 3 plus 1 times 2 again, divided by 2. The 2's cancel out. 2's cancel out, and you just get 6 minus 4, so you get 2. So 2 is the answer. All right, let's go to the next one. If you need to pause it whenever, guys. The key here is they're trying to check to see if you know your properties. So this really is the integral of 4x e to the negative 10x squared plus 3x ln e, which is just 1 dx. So I'm going to split this up into two integrals. I'm going to use u substitution for that dude there. So I'm going to write it like this. 4 integral x e to the negative 10x squared dx plus integral of 3x dx. And let's see, I'm going to do u sub for this guy here. I'm going to say u is a negative 10x squared, so du is going to be a negative 20x dx. So yes, I know that I can multiply by 5 and make that a 20 and then divide by 5. But let's just make life simple. Put a 20 there, put a 20 there. There's your 1/5. Negative 20, right? So negative. So there we go. So now here's what we got. We got a negative 1/5 integral of e to the u du. So that turns to negative 1/5 e to the u. So replacing the u, what was u? 10x squared. So negative 10x squared. And then the antiderivative of 3x is just 3x squared. Hold on. What was that crap? Okay, I don't know. Something funny there. 3x squared over 2 plus c. And look for that. So let's see. This guy. Oh, you got it right. Good job. Good job. All right. Go to the next one. This one looks like it's an ln, and I see an x in the bottom. So I'm tempted to do u sub. And I'm going to do ln is equal to ln of 2x cubed. So then that means du is equal to 1 over 2x cubed times the derivative of that, which is 6x squared. So let's see. Oh, with a dx on it. So, with a dx on it. So here's what I see. 2 goes into 6 3 times, so 3. Those x squares cancel out with those. So I see 3 over x. Well, I have an x down there. I just need to put a 3 there and a 1/3. So now we have, let's see, 1/3 integral of u du. That's what it looks like. And now just take an antiderivative. 1/3 times u squared over 2 plus c. So 1 over 6, and then plug back what u is. U is 11 2x cubed. So 11 2x cubed, close, put a square on it. And I put a plus c, and then I look for that. There it is. Let's continue, guys. Find the area of the region bounded by the curves 4 minus x squared and the x-axis between negative 5 and 2. So 4 minus x squared, this intercepts the x-axis at positive and negative 2. So it looks something like this, where here is a positive 2, here is a negative 2. I want all this area here, and then I want a little more. It looks like they want to go from negative 5. So from negative 5 to, I'm going to exaggerate it. I'm going to say they intersect there. I want all that area right there. Okay, the first thing I would do, I'm tempted to find the area between 0 and 2, whatever that is. I'm going to multiply by 2 because it's symmetric. This area, I know I didn't draw it perfect, but that area should be the same as this area in green here. So that's what I'm going to do first. Let's see. Integrate 0 to 2. I'm going to multiply that by 2. And I'm going to go 4 minus x squared dx. So let's see. 2 non-derivative of 4 is 4x minus x cubed over 3 from 0 to 2. I just got to worry about the 2 then. So 4 times 2 is 8 minus 2 to the third power is 8, so 8 thirds. And let's see, let's continue. 8 times 3, 8, 16, 24, 24 minus 8. So 16 over 3. So 32 over 3. Let me know if I made any mistake. I don't think I did, but if I did, let me know. Let me just check it real quick, guys. I don't want to lie to you guys. Okay, that's correct. All right, so now I'm going to find the area between -5 and 2. So I'm going to add, so I'm going to go -5 to -2, sorry. And this is obviously going to be negative, so I'm going to turn it into a positive. You know what, let's do that right now. 0 minus 4 minus x squared. So there, now it's going to turn into a positive because I did 0 minus this graph. So dx. So now I'm going to have -5 to 2 of x squared minus 4 dx. Alright, let's see what that number is. It's going to be positive now. So I have x cubed over 3 minus 4x, and I'm evaluating this from -5 to -2. So let's plug in a -2 in there. If I plug in a -2, I'm going to get, let's see, -2 to the third power is a -8 over 3. And then 4 times -2 is -8, but I have a negative there, so plus 8 minus, if I plug in a -5, -5 to the third is 5, 5, 25, 25 times 5, 125, but negative over 3. And then if I put a -5 there, 4 times 5 is 20, but negative, so negative times a negative is a positive, so plus 20. And let me see what that is. Take my little calculator. -8 over 3 plus 8 minus -125 over 3 plus 20. And I get 27. So now I add that number and I add this number. So plus 32 over 3. Oh, 27 plus 32 over 3. And I get 113 over 3. There you go. Sorry, sad face. But now you know how to do it, guys. Pause it or ask me questions if for some reason you don't understand. Soul fields are pretty easy. I'm tempted to skip this one, but in case you're having troubles with it, here's how I would do it. Choose a particular vertical, horizontal, and vertical. Notice that as I go more and more right, the slope is affected by x. See? Now look, if I look up and down, notice that if I go down this vertical line, the slope is affected by y. So it's affected by both x and y. So I should look for an equation that has x and a y in it. Out, out, maybe, maybe, out. So it's between C and D. So I notice that I have horizontal or zero slopes all throughout the line. And this line looks like it's y equals x. Do you guys see that? Yay. So, sure enough, this guy here, that equals 0 whenever y equals x. So, it's letter D. So there it is. Yay. Yay, happy face. Alright, let me take some Red Bull here. The good stuff, the sugar-free, guys. Yeah, it keeps me going all the way to midnight, hopefully. Alright, here we go. This one, I guess, is a medium one. So first thing I would do, it wants to see what f of -1 is. First thing I would do is turn everything to dy dx and x and y's and all that good stuff. So 3 dy dx plus 3y equals 0. And then I'm going to move this 3y to the right. So 3 dy dx equals a negative 3y. And what feels right? I think I'm going to move this y to the left and move that 3 to the right. So let's see. dy over y equals negative 3 divided by 3 is a 1, or negative 1. So negative dx. So I multiplied by dx and I divided by y. So there we go. I'm going to get rid of the dy and dx's, and I do that by integrating. If you want to put a 1 there, you can. So I'm going to have ln, absolute value of y, equals, and negative x plus c. So then I'm going to put an e here and an e. So let's see, I have absolute value of y equals e to the negative x plus c as an exponent. But remember, your laws of exponents, this guy here is the same thing as saying e to the negative x times e to the c. Well, e to the c is just some constant. Some constant. And since it's just some constant, I'm going to let this guy tell me whether the y is positive or negative. And as you can see, it's positive there. So I'm going to rewrite it. I'm going to take out the absolute value. Chavez, why are you taking out the absolute value? Because I'm letting that constant determine whether my y is positive or negative here. So, of course, the situation, I'm going to let the situation determine that. So here we go. We have that. And I'm going to plug in 1 and a 6 in there. So 6 equals c e to the negative 1. So that means that divide. So that means c equals the number 6 divided by e to the negative 1, which is just 6e. So here's my equation. Y equals 6e, e to the negative x. And of course, that just looks funky, right? So rewrite it. 6e to the negative x plus 1. So there it is. So now, let's see, what do they want? F of negative 1, so let's plug in a negative 1 in there. So if I plug in a negative 1, I get 6e, negative times a negative is a positive, 1 plus 1. So 6e squared. There you go. Cool. All right, let's continue. Let's do this guy here. So it wants a second derivative. First, you got to rewrite it, guys, where you can take a derivative. You want this variable in the top. You want that constant in the bottom. So when you do that, put a negative in the front. So negative integral 0 to x square root t squared plus 4 dt. That's really a dummy variable. You can call it whatever you want. Here we go. Take a derivative, f prime. When you do that, you get negative square root x squared plus 4. You're done. Well, okay, well you're not quite done. I would rewrite it. Negative on the outside, x squared plus 4 raised to the power half. And now I'm going to take another derivative. So here we go. Negative 1/2. Leave the inside alone. Subtract 1, so negative half, times the derivative of the inside. So rewriting it, let's see, those two guys cancel out. You get x over square root x squared plus 4 with a negative on the outside. So that guy. I kind of want to skip this one, guys, because we've done many of these before. But, you know, if you don't want me to, I won't. So I guess let me just do it really quick. Find the volume of the solid generated by revolving the region x equals y squared. So x equals y squared, that means it's a parabola that's opening up on the x-axis. So it looks something like, and then 2/3 x equals y plus 2/3. So that is just, this equation is just y equals 2/3 x minus 2/3. So probably something like, let's see. Something like that. And I'm going to rotate this about the y-axis. So there's the region. I don't know if you can see it. So it's going to look something like, let's see. Something like that. So here is my cross sections. And as you can see, they're washers. So I need to figure out this low value, and I need to figure out this high value. So how do we do that? Simple. Let's see, these are y values that we want. So I'm going to multiply this by the reciprocal here. So let's see, we have x equals y squared, and we have x equals 3 over 2y plus 1. So I'm going to set these two equal to each other, guys. So y squared equals 3 over 2y plus 1. I don't want fractions. Multiply everything by 2. 2y squared equals 3y plus 1. Move everything to the left. 2y squared minus 3y. Oh, did I do everything correct? Let me make sure. Multiply. Nope, I didn't do everything correct, guys. Right there. That should have been a 2. So minus 3y minus 2 equals 0. So let's see if I can factor this out. Let's see. 2yy. I want to add up to a negative 3. 2, 2, 4. That have to be a 1 and a 2. Am I doing it right? Is this right? Hold on. Hold on. La 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 la. Alright guys, I don't know why I had such a brain fart, but yeah, no, we're doing well. This would have been 2y plus 1, and this one has to be y minus 2. Let's see, 2y times y, 2y squared. 2y times negative 2 is a negative 4y. 1 times y is plus 1y, so there's a negative 3y. 1 times negative 2 is negative 2, so there it is. So my y values are 2 and negative half. So down here, that y value is a negative half, and up here, that y value is a 2. So I'm going to integrate, and it's always a washer everywhere. So I'm going to integrate pi from negative half to 2. And the big R is this linear line, which is this guy right here. So that guy I'm going to write as 3 over 2y plus 1 squared minus, and then the little r is this guy right here. So that's just y squared. Y squared squared. And then I wouldn't bother. Just type it in the calculator, guys. So here we go. Integrate. Alright, guys. Finally, when you type this into your calculator, you get this dude. Make sure don't include the pi in there if you want to get the 125 over 16 perfect. Let's continue. The base of a solid is a region bounded by y equals 2 to the negative 2x, the x-axis and the y-axis, and the line x equals 1. Each cross-section property of the x-axis is a semicircle. The volume of the solid is... Alright, so here's how it looks. 2e to the negative 2x, more or less, looks something like that. And the line x equals 1, so I'm exaggerating it. Here's x equals 1. And each cross-section perpendicular to the x-axis is a semicircle. So here's my cross-section. So that line that you see there, it's coming out of the board, or coming out of this laptop here, and there it is. So this line here that I'm bolding is this line there. So first think about an area cross-section. So here's my area cross-section. So pi and then r squared. So the radius, this is my diameter here. So 2e to the negative 2x, whatever that is, divided by 2. And that's my radius. And whatever that is, divided by 2, because we're talking about semicircles. So it's going to look something like this. Let's see, pi over 2. These 2's cancel out. E to the negative 4x. So that's what I'm going to integrate. So here we go. Volume equals pi over 2 integral from 0 to 1 of, oh, I don't need that square anymore because that's how I got the 4x there, guys. 2x times 2 is 4, negative 4x. So e to the negative 4x dx. So now, pi over 2. Let's see, antiderivative of that is e to the negative 4x. But I don't have a negative 4 in the front, so that means I have to have a negative 1/4 here. So I can get a 1. See? When I multiply negative 1/4 times negative 4, it's just 1. And I evaluate that from 0 to 1. So you're going to do both. I'm going to go ahead and factor that negative 1/4 out, guys. Pi over 8 negative e to the negative 4 minus e to the 0. Remember that e to the 0 is 1. So I'm going to distribute. And you get a positive pi over 8 from this guy minus pi over 8 e to the negative 4. So now we look for that. There you go. Let's continue. This is straightforward U substitution, guys. Make u equal to that on the inside, and then you'll see that, let's just do it just in case. U is 6 plus 3x to the n. So du is 3n x to the n minus 1 dx. So this is missing a 3n. And you put 1 over 3n on the outside like that. So here we go. 1 over 3n integral square root of u du. 1 over 3n times u to the 3/2 times 2/3. Let's see, did I do that right? Half? Yeah. Plus c. So let's see. 2 over 9n, and then in parentheses, 6 plus 3x to the n, close it to the 3/2 plus c. So let's look for that. Is it this first one right here? It looks like it is. Let's make sure. Nope, it's not that one. There's no n there. That one. Alright guys, here we go with this one. So move this to the right first. So y dy dx equals 2 plus y x squared. And then I'm going to move the 2 plus y to the left and the dx to the right. So y over 2 plus y equals x squared dx. I'm going to integrate. So type this into Wolfram alpha. There's a dy here. Sorry. So this is the tricky part right there. When you do that guy, it comes out to, I'm doing it right now, guys. I'm going to integrate. It's divided by n plus x plus gamma x. So I get y minus 2 ln absolute value 2 plus y, close it, equals x cubed over 3 plus c. Now they tell you this guy, so let's use that. When x is negative 1, I'm sorry, when x is negative 3, the output is negative 1. So I'm going to type negative 1 minus 2 ln absolute value 2 minus 1 is 1. ln of 1 is 0, by the way, equals negative 3 to the third power over 3 plus c. That goes away. Negative 1 equals negative 3 to the third power. We'll take one of those out. So negative 9 plus c. So plus 9. So c looks like it's going to be negative 8. And I just start looking for that. So y minus 2 ln 2 plus y, can't be that one. It looks like it's almost that one. Y minus 2 ln 2 plus y, 1/3. There it is right there. Oh, wait. Nope. That's plus 8. Oh, man. Did I make a mistake here? Oh, yeah. I did. Plus 9 plus 9. That's a plus 8. How come you guys didn't tell me? Man, shame on you. No, I'm kidding, guys. LOL. All right, here we go. The function f is differentiable. Determine the value of f prime. Well, here's f. You're going to have to take a derivative so you can get it to be f of x. And then you're going to have to take another derivative because you want f prime. So if I take a derivative of this, you get 3f of x plus 4x equals, the derivative of cosine is negative sine x. And now we're getting ready to take another derivative. 3f prime of x plus 4 equals, the derivative of sine is cosine, but keep it, there it is. And move the 4 to the other side, divide by 3. 3f prime of x equals negative cosine x minus 4. Divide by 3, divide that sucker by 3. So finally, f prime of pi over 3. So here's your pre-cal. It never goes away, guys. So cosine of pi over 3 is a half. I have a negative half there, minus 4, all divided by 3. So I think we can do this without a calculator. Let's see, 1/2 and 4, that's 4.5. 4 times 2, 8, 9. So that's 9 halves, but negative, divided by 3. So that's negative 9 over 6, so negative 3 halves. And there it is, guys. For what value of k is the following equation true? Well, this is a NOT function here. So this is true if k is a negative 3 or if k is a 3. So that one really wasn't much of a challenge, guys. Straightforward. You just got to know about your even and odd functions. For an even function, f of x with an average value of 3 on the interval negative 3 to 3, determine 0 to negative 3. Okay, so remember that your average value is 1 over b minus a integral from a to b of f of x dx. So that means, let's see, with an average value of 3. The average value is 3. So 1 over, the difference between negative 3 and 3 is 6. So 1/6, or 3 minus negative 3. Integral from negative 3 to 3 of f of x dx. This was equal to 3. Times 6 times 6. So now we have integral over negative 3 to 3 of f of x dx is equal to, let's see, 6 times 3, 6, 12, 18. 18. So if this equals 18, that means the integral from 0 to negative 3, counting backwards, guys, must be a negative 9. Let's see, what is the approximate instantaneous rate of change? You're going to need your calculators because I can see decimals here. So take the derivative of this because it wants instantaneous. So that should tell you that you're going to be taking a derivative. So f prime of t is equal to 4t sine, so not 4t, 4x. 4t. 4t sine 4t. And then you got to multiply the derivative of 4t, which is times 4. So f prime of t is equal to 16 sine 4t. And now I plug in a pi over 5, so 16 sine of 4 pi over 5. And I take my little calculator and I just type it in. 16 times sine of 4 pi over 5. And I got 9. I didn't get any of those answers. That sucks. Let me check again. Hold on. The derivative f prime of t is equal to 4t. What is the approximate instantaneous rate of change of f of t? 0 to 4t. 4t sine of 4t times 4. That's correct. Oh, guys, why don't you tell me there's a t here? 4 times 4 is 16, but there's a t right there. Lame. Okay, so 16 times 4 pi over 5 sine of 4 pi over 5. So here we go. 16 times 4 pi over 5 times sine of 4 pi over 5. 23. Oh, I still didn't get anything. I'm in radian mode. Is there something I am missing? 16 times 4 pi. Oh, mistakes galore. Man, Jesus Christ. That should be pi over 5. That guy's 4 pi over 5 because of that 4. Finally, we got an answer. 5.909, so 910. Sorry guys, just fast forward there I guess, or whatever. Use the table below and the left endpoint with n equals 5 to approximate 0 to 2. Okay, so I can see here 2, 4, 6, 8, 10, or 1, 1.2, 1.4, 1.6. They're going by 0.2s. This n equals 5 means that they have 5 rectangles. So that means each rectangle is going to have to be 0.4. There's my first one, there's my second one, there's my third one, there's my fourth one, there's my fifth one. And you're using LRAM, so that means I'm using the leftmost point. That's the point I'm going to use. That's the point I'm going to use. Let's see, this is the point I'm going to use. So there it is, 1, 2, 3, 4, 5. So each width is 0.4, right? So I just go 0.4, and then I just write 3.8. It's width times height, width times height, width times height, but I'm just going to factor the 0.4 out, guys. 3.8 plus 2.9 plus 2.9 plus 2.9 plus 3.2. And whatever that is. 1, 2, 3, 4, 5. I got them all. Whatever that is, guys. Let's go ahead and proceed. Go to the next one. Ooh, I like this one. This is one of my favorite ones. Let R be the region in the first quadrant bounded by the graph y equals kx minus x squared in the x-axis. Determine the value of k such that the area of R is 243 over 2. All right, so this is a parabola, and if you factor out an x, you can see that you cross the x-axis at k and at 0. So it looks something like that. 0, k. And I want this area here to be 243 over 2. So I'm going to integrate from 0 to k that equation. Kx minus x squared dx. So antiderivative, kx squared over 2 minus x cubed over 3. And this is evaluated from 0 to k. And that better equal 243 over 2. So here we go, guys. I'm going to plug in a k. So k squared times k is k cubed. So I have k cubed over 2 minus k cubed over 3. And I'm going to get a common denominator. So multiply this by 3 over 3. Multiply that by 2 over 2. So you're going to get 3k cubed minus 2k cubed over 6 equals 243 over 2. So now you have k cubed over 6 equals 243 over 2. And let's see, I guess I would cross multiply maybe, or whatever you guys think is easier. So I'm going to change colors here because it's getting pretty clustered here. 2k cubed equals 243 times 6. I guess you could have also done 2 goes into 6 3 times. It doesn't matter. 1458 divided by 2. So I get k cubed equals 729. And I'm assuming that's a perfect cubed, and it is. Perfect cubed. If I take the cube root of that, you get k equals 9. 9 to the third power is 729. Yay! Alright guys, let's keep going. So this one's straightforward. You're going to need a calculator. Think of this as velocity, and think of this as position at 3, at t equals 3 or x equals 3. So they want the position at 8. Position at 8. t equals 8. So what you do, f of 8 equals your initial position, f of 3, plus the displacement. You're going to integrate from 3 all the way to 8 of f prime. And that's how you do them, guys. It's pretty straightforward. Nothing, not a big deal. So you think of this as position. Your position at 8 is the position at 3 plus the displacement. So think of f prime as velocity and f3 as initial position, or position at 3. So if you find your displacement, yeah, of course you're going to find where you're going to be at your position at 8, your initial position at 3 plus the displacement between 3 and 8. That's going to tell you where we're going to be at 8. So just do that. It's pretty straightforward. This one's exactly the same. The solid ball is made out of a composite material. The temperature T in degrees C and time T hours of the center of the ball satisfy the equation blah. If T of 0 is 30, then T of 40 is same. Do the exact same thing. T of 40 is your temperature at 0. And then you're going to integrate T prime, because this is going to tell you how much the temperature changed, guys. So you're going to integrate from 0 to 40 of T prime. T prime, T, dt, doesn't matter. So this tells you how much the temperature changed between 0 and 40. Temperature change between T equals 0 and T equals 40. And then you just take your temperature at 0, 30 degrees Celsius, and you add to it, and that's it. So do that. That's pretty straightforward. Find the area of the region bounded by the graph. Sine x cubed minus 3 plus x over 6. I'm going to give you an easy way, guys. If they want the area of this between 0 and 5, here's the easiest way to do it. Integrate between 0 and 5 of the absolute value of sine of x squared over 3 plus x over 6. And that will always work. Always, 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 always. There is other ways to do it, but I think that's the easiest way. Don't be a robot. It's very easy to become a robot. If you don't understand the mechanics of why this works, please ask me and I will go into detail. All right, let's go to the next one, guys. See notes on this one. We've done it before. See previous notes. It's the same deal. Y equals y naught e to the kt or c e to the kt. Doesn't matter. See previous notes. We have that on that. The region above, y equals 2x, and below, y equals is rotated around the x-axis. Give the volume of the solid generated. We've done this. See your previous notes. If you're having problems with this, ask me and we'll do it. But yeah, see previous notes, guys. It's in there. Find the number C on the interval for which f of c is equal to the average value. Okay, so this, I don't think we have done this, but you may not remember. All right, so here we go. Find the average value of f of x first. So 1 over 3 minus 1 integral of 4x minus 2x squared dx. Between 1 and 3. So we do that, and let me do that really quick. Integrate 4x minus 2x squared, comma 1, comma 3. I did this earlier by hand, guys, so you guys should at least make sure that you guys know how to do it by hand. But once you get the hang of it, I guess it's fine. Times a half. So I get a value of negative 2/3. So then it says find the c on the interval 1 and 3 for which f of c. So they're talking about f of x. So I'm going to write 4x minus 2x squared equals negative 2/3. So you can do this either by putting this in y1, putting this in y2, or if you have an Inspire, set y1 equal to y2 and just solve for x. Whatever method you think is easier. But make sure you know how to do it though. 4x minus 2x squared equals negative 2/3, comma x, close. And I get, hold on, let me get a decimal here. I get negative 0.154, but that's not in the interval. And I get 2.15. So there it is, 2.1547. All right, let's keep going. If the velocity of the particle is moving horizontally given by blah, find the total distance traveled. Remember that distance equals the integral from 0 to 2 pi of the absolute value of your velocity. If you just integrate velocity, that is displacement. But if you put absolute value in it, that's distance, guys. So just do that and you'll get your answer. This one you're going to have to complete the square. Is this the last one? Oh yeah, awesome, cool. So you're going to have to complete the square, and so let's do it. So first complete the square. 1 over, I like red better. I hope you guys like red better. X squared plus 2x, and I'll put plus 7. 2 divided by 2 is 1, and 1 squared is 1, so plus 1, minus 1. I put that minus 1 for balance. For balance. Okay, so now this turns to that. So now what I want this 6 to be a 1. So you do that by dividing by 6, dividing by 6, dividing by 6. See? So now everything's still the same. So now here's what I have. 1/6 integral 1 over x plus 1 over the square root of 6 squared plus 1. So now I write u equals x plus 1 over the square root of 6. So du equals 1 over the square root of 6 dx. So I have a 1/6 here, but I'm going to write this as 1 over square root of 6 times 1 over square root of 6. So there it is. So there's my 1/6. So now no need for balancing. 1 over square root of 6 integral 1 over u squared plus 1 du. That is arctan. So 1 over square root of 6 arctan of u plus c. And then we plug back what u is. 1 over square root of 6 arctan of, let's see, what do we have? 1 plus x, x plus 1. X plus 1 over square root of 6 plus c. Alright guys, I hope you enjoyed the video. We covered every single question, but maybe one or two. We did all of them, except for maybe one that I put C notes, and then some of them I didn't calculate, but I put the work there. So please watch the video first, and then if you have questions, ask me. So I hope you liked it, guys, and I'll see you guys later. Alright, bye.